Hello YouTube. Another day, another laptop to repair. Today in front of me I have an Acer Nitro. Just like most of the Acer Nitros we see, it's been sent in for a no power fault. Acer Nitros suffer a lot of short circuits, so the first thing I'm going to do is pop the back off and check the 19 volt rail or the high side rail to make sure that's not short circuit, and we'll go from there. So, the first thing we're going to do is try and find the 19 volt rail, and then we're going to check if it's short to ground. So, the 19 volt rail will show up on the input to any buck regulator. This chip here will take 19 volts and shoot out a lower voltage on this inductor. I'm not sure what voltage this inductor will output when it's working, but what I really care about is the 19 volt input right now. So, I'm going to check if that's short to ground. Just measure between that inductor and any ground point there. And we get 1 ohm. My multimeter is not very stable today by the look of it. But yeah, we just about less than 1 ohm on that 19 volt power rail. So there's definitely a short circuit we need to find. The next thing I want to do is figure out what's shorting to ground. The way I like to do this is I'm going to check some other coils on the board and make sure they're not short as well. So the first most important thing is the CPU. Under this heatsink, we've got a bunch of MOSFETs to power the CPU. They take 19 volts and drop it down to, I think, 1 volt or so for the CPU. So what I'm going to do is I'm going to try and get my probe just in that little hole there to find one of the inductors for the CPU core voltage and measure between that and 19 volts. Okay, that's not good. So we have 0.2 ohms there. Now remember the value earlier. So between ground and the CPU, we have 2 ohms, but between 19 volts and the CPU, we have 0.2 ohms. That means that the CPU is connected directly to the 19 volt rail, which means one of these MOSFETs under the heatsink is going to have failed and sent 19 volts into the CPU, which means this system's toast. Let's pop the heatsink off, figure out which one of these MOSFETs are dead, and then we can, see if we can do anything about it. So here we are again, and the heatsink has been liberated. So let's check again. We have on the 19 volt rail 0.4 ohms to ground and 0.1 ohms to the CPU. So because the resistance is lower between 19 volts and the CPU than it is between 19 volts and ground, we know without doubt that one of these 4 MOSFETs has failed. This one we can ignore, it's CPU GT. So that CPU GT measures 9 ohms, which is fine. So this MOSFET's going to be okay. So now I've got to narrow down which one of 4 has failed. There are a few different ways to do this. The quickest I find is just to check the resistance values on the gate of each MOSFET. I'm going to do this in diode mode. And we look for abnormalities. So 0.4, 0.4, 0.9, 0.4. Other gate, 0.4. Short circuit, 0.4. 0.4. So it's this third FET here is bad. Let's just mark that. So this one's failed, connecting 19 volts directly to CPU core voltage, which means the CPU is probably going to be bad. When this shorted out, it will have drawn a lot of power. So the next thing I'm going to check is the inrush MOSFETs just by the DC jack. I do this because when this failed, it drew a lot of power. If the charger was connected, all of that power will have ran through the DC jack and through this first MOSFET here. This would have probably overwhelmed and killed the MOSFET, so let's just check that. We can stay in diode mode for this. And 0. And 0 to the gate as well. So this is quite typical with a short on the high side rail. As soon as the short occurs, it overwhelms this FET and it blows this FET out. We could leave that FET on the board and fix the short circuit and it would still turn on, but the charge IC would get a bit unhappy with that and it would refuse to charge the battery. So yeah, always check the first MOSFET if you've had a short on 19 volts. It's about 50-50, but quite a lot of the time this FET will fail as well. So let's take the board out. Let's find a suitable replacement for this FET and for this FET. Then we can plug it in and see what it does. Place that there to not melt those caps. Well, that worked. Let's try again. Use my heat gun to help these joints along a little bit. Good enough for me. There we go. So let's recheck for shorts. And on 19 volts, we have 0.3K now, which is good. This first MOSFET here, yeah, that's okay. And it's not short to the gate either. CPU resistance, 0.7 ohms to ground, which I think is low, as I expected. This is a common fault, so this is not the first time I'm seeing the CPU power supply fail on these Acer Nitro boards. It's been a while since I've worked on one, but we see it, at least we used to see it all the time. These systems are a bit older now, they're 10th gen, so we don't get them in for repair quite as much, but yeah, most of the time if I see an Acer Nitro, I suspect bad CPU. Anyway, so this resistance is Yeah, a little low, 0.6 ohms. So this CPU is probably trash. The other thing I want to check is I want to recheck the gate values to ground, just to make sure that there's not a problem elsewhere in the core regulation circuit. So we now have 0.39. It's a little warm, so that's a little lower than that value we got earlier, 0.4, yeah. And this one, 0.4 as well, which is close enough. If these values were different, then it may be, sometimes when these FETs go, they can kill the PWM doubler that controls these FETs, and it will work even with a dead doubler, except this FET will fail again. So yeah, if these values were different, then I'd have to look into what sends these gate signals. Now, on these boards, there is chips on the back, here, 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 and here. So each of these chips corresponds to a MOSFET, and this sends the gate signal. If one of these dies, then the MOSFET won't work properly. It will overheat and it will kill a new MOSFET. So it's always worth checking your gate values before you power on a board that has had a MOSFET replacement, because the MOSFET could fail again. So, I mean, I think the CPU is dead, but I'm going to pop the heatsink back on, plug it in, turn it on, and see what it does. There's the power pads. Ah, there they are. Okay. Okay, did you guys see that? It drew 2 amps. Go straight to 2 amps. Current keeps increasing, and then it cuts out. So yeah, this thing's not happy. So yeah, it's got no power still. It draws 2 amps and then turns back off. So I guess I'm going to have to talk to the customer, tell them the bad news, tell them that they need a new laptop because this one has a bad CPU, which makes it unfixable. Thanks for watching. Hopefully we have better luck in the next video. Goodbye. Sometimes you get to the point in repair and you think, well, this is going to be difficult, but I really want this laptop to work again. And I suffer from that quite badly. I don't like letting things go out as no fixes, especially when I know I can fix them. So, the customers agreed to a new CPU. Let's get that fitted for them and see if it works. So this CPU, the original, is SRH8Q, which I think is an i7-10750. And what we're going to be doing is replacing it with an SRH8T, which is the i9 variant of the 10th gen CPUs. Okay, the board is ready for its brain transplant, so let's chuck it on the rework station, get this old CPU off, and get it ready to fit the new one. So, there we go, I fitted the new CPU. Put some new thermal paste on there. Yeah, I plugged it in. It looks like it's turning on. I used this Vertianov Successor Programmer to verify that it had activity on the USB lines. So we're just waiting now for it to paste and see if it boots. Yes.
Nice.
AliExpress CPU for the win. Looks good. Just go to BIOS. Not sure how well you're going to see that. CPU is now showing as an i9 10980HK. Running at 47 degrees, which looks happy. So there we go. Brought this laptop back from the dead by replacing the original CPU and 2 MOSFETs. Cool, good stuff. I'll get this tested, make sure it runs stably, run some stress tests on it, and this one's ready to go back to the customer. And next, in my queue, we have an Acer Nitro. And typically, it has a short circuit. I don't know what Acer was smoking when they designed this CPU core supply circuit, but it's not very reliable. There's a reason I bought 2 CPUs. Time to get on with the next one.
And with that, I'm going to say thanks for watching. If you liked this video, hit that thumb up button and subscribe to see more laptop brain surgery. Goodbye.